Nats FM is brought to you by Synadia, the stewards of the Nats project.
Hey, so welcome to episode 5 of Nats FM, and this one's a little bit different from the normal perspective of two white dudes floating around in a black background. We've now got 3 white dudes floating around in a black background, and for those listening in audio, we have a special guest, and he's one of our superstar engineers. Would you like to introduce yourself?
Hello, I'm Tomasz. I'm an engineer in Synadia, working here for, oh my god, it's a year and a half already. I'm a lead engineer in the client team, leading the client efforts across different languages, though my main responsibility is the Rust client, help with the Go client, and the NAT server, plus various contribution across other repos.
Of course.
Most of the repos for the NATS probably project, though that's my main area of work around NATS.
And just for clarity, you're the lead engineer or the elite engineer? Because I didn't quite distinguish that from the beginning.
Yeah, the tech lead of the client team. Let's rephrase it this way.
Aha, still an elite engineer though. We'll take that.
And Tomasz is the one who brought the magical Rust client to.
Yeah.
Yes.
We did. That was the first thing when I jumped into the company was to write again the Rust client using the async Tokyo API, which was really fun journey.
That sounds like another episode altogether. So before we dive into the content of this episode, we're going to just, I guess, do all the usual pleasantries. Byron, how are you? Good week?
Yeah, it's been a good week. Busy week. Focusing on getting 210 out the door, right, Tomasz? It's a lot of things around that.
Yeah, I think that's the answer of most of us this week. Is focusing on to the 10. For most of the client folks, the same. It's really nice to see so many people focused on making sure it's going well, it's stable, all the tests are green, etc. So yeah, that's the same for the client, and I think for the most of us.
So I was going to ask how you were as well, Tomasz, but I think you've just said it. It's another 210 journey week.
Yeah, it is. More and more confident with each day. But that's the main focus. Plus, making sure, of course, last moment realizations that did we miss something on the client side, or we didn't? Did we misunderstood something? But so far, so good.
I think that's the thing, isn't it, with the ecosystem? Everything is so, I guess, dense with features, and across the various clients, trying to make sure that there is stability, feature coverage, and a kind of similar, I guess, consumption. Approach, maybe. I don't know. You're the client guy, but it's hard work.
That's the challenge. There's a balance we try to reach. Meaning, on one hand side, you want the clients to be similar in some sense, meaning that similar patterns are available, that you can do the same things using NATS. But we don't also want to fall into the trap to make each client the same, meaning they don't feel like a idiomatic code for engineering specific language, because it's probably only for us, NATS engineers, Synadia engineers, to think that people care that the clients are so close to each other as possible. People usually prefer that their clients are, even if they work with more than one, that each of them is idiomatic up to the idioms of the language. But at the same time, you need to find some similarities between the languages. So yeah, this is an ongoing challenge that was probably first tackled in way that we all try to find a common ground is for the simplification and new JetStream API. That was the first time we tried to get it.
Beautiful.
Which is like a nice
beautiful segue. But yeah, and just for people who are like, oh, 210. Well, there's going to be an episode after 210's release, so we're not talking about that today. But that was a beautiful segue. So let's talk about JetStream modernization. What motivated that? And being part of many of the conversations with the client team, myself, just observing in the background, you made that point of saying, how do you introduce provide the same capabilities across the clients, but still achieve the idiomatic nature of those languages. And of course, what motivated the modernization in general.
Yeah, so that was one. I mean, the first main, most important idea for us was that when we were doing the first implementation of JetStream, which was mostly for Go, the goal and our idea was then to provide an API that is similar to the Core Nuts API, meaning that you still subscribe and then the client handles all the details of JetStream underneath. And it was a really nice idea. But as the JetStream was growing in its capabilities, consumers were growing in things you can do with them, how different they can be. It became this subscribe method that looks like Core Nuts. It was actually jumping people from Core Nuts to JetStream without learning about the JetStream. And because of that, creating a lot of surprises and unexpected situations, like people didn't even realize that the consumer is server-side construct. So we realized that, and we had a lot of Slack discussions with folks clarifying what actually happens on the subscribe. And even with time, it was harder even for us because those methods were enclosing so many different behaviors that it was getting harder to grasp as the server capabilities for JetStream and consumers were growing and expanding. So that was the first spark that we probably have to do something with it. And we called it simplification, despite now you have to call a little more methods to get to where you were with the subscribe. But you explicitly have to do those things with interact with the server or with the cluster or whatever topology you have to get the result. So that that actually gives the idea for the engineers, even without reading about JetStream and reading about those deep dives and viewing our videos about it, that I have to create some stream, I have to create some consumer, now I can use it. So it's very I think it's more we try to be more expressive with what's happening when you try to use JetStream. So that was one of the goals. So the first idea was, let's just change the subscribe and let's tell users you have to explicitly create those resources on JetStream, streams, consumers, and etc. But then we thought that's probably the only opportunity we have in quite a long time to, in general, improve the JetStream API, because we try to be as non-breaking as we can, but that's again a different compromise you have to make, right? If you don't want to break customers, users, it's hard to iterate over the API. So you realize that this is the opportunity we have to take, the only one for the JetStream to improve, and that's how the project gets a little bigger. So this is one part of the story, not the only one, to be fair, because the other one is that we also wanted to move to, as the thing that we mentioned at the start as a segue into this discussion, which is the approach we had in the past was mainly that we implement the first client in Go, and then we try to make it similar in other clients. So we have our role model Go client, and then others following it. And we never discussed how close they should be or how far. We just try to deliver the features to everybody. And this was the first time, and then we tried, actually this is one of the outcomes, and we discussed how in general we want to work with clients. That, for example, the thing that you can see right now in the new API and different new APIs, the same for the service, could be a segue to another discussion, but it will be digression instead of discussion, instead of segue. So I think it was very important to find that engineers and maintainers know how far they should push towards being similar APIs to each other and how far to the idioms. So that means that, for example, before most of the calls to getting the messages, it was the callbacks, because that's how you do things in Go, right? While Go don't have the iterator interface, usually use callbacks. And for such, especially such things like subscribing to messages, etc. And other clients follow it, but not in every language. It's an idiomatic approach to get stream of something. In many of them, it's, for example, iterator or something else. So we try to find those hooks on the JetStream API that will make it similar in structure across all the languages and similar naming, similar verbs, but still depend if it's like get something or something. It's depending on the language specification, language idioms, and the same applies to callbacks versus iterators, how callbacks are structured. So we try to set it in this way so that each language has the similarities that you can orient yourself in the library, even if you are first time here, but you use like your first time using JavaScript, but you use Rust for a year, you should be fine because you know how idiomatic Rust or JavaScript works, but you also don't have to rediscover the totally different approach to using NAS on the client side, because the orientation points are the same. So that's where we landed, and it also translated to all new APIs that we try to design. So we have those orientation points, some verbs, some nouns that we agree upon, but everything else is just keeping to the idiom. So that was the second goal, or rather side effect, that we realized pretty quickly that we have to deliver this to have nice experience and good story for the JetStream.
So I had two follow-up points to that. I think to your point of simplification, I think it's cognitive simplification. So even if you have a couple extra things that you have to do to say configure consumer, it's more explicit, right? It's more expressive in how you're setting this up, and it's more obvious. Like you said, there's no surprises that you have a stream, you in fact create a consumer. I think even along, the past 6 months to a year, this ability and this whole idea of an ephemeral consumer versus a durable has been sort of reduced down, and to make it that a simpler concept for people to say it's ephemeral based on, some inactivity threshold, right? There's no activity and then it just goes away. Or if you want full control over that, you say, don't clean it up, server, for me. I want to explicitly delete it. And so I think with the simplification, all of that has become more obvious, rather than you doing, the js.subscribe in the Go client, also not manually acking, it's auto acking for you. And you're like, well, what's the behavior of the underlying consumer? So it wasn't clear for beginners, even though it was akin to the Coronats API. But there's a lot more going on behind the scenes, which I definitely agree, I think was surprising for a lot of people. So I've really, and I know the whole team has gotten great feedback so far, positive feedback on simplification, the new JetStream API. So that's really, really good.
Yeah, the ACK is a nice point to make, because it was a great example of seeing how, it sounds nice to just, people don't have to care about those ACKs. And then they were surprised that it's ACKed, or if it's not ACKed, and it made it, even if the code looks simpler, the cognitive load was bigger, and it was even harder to have it, similar in different clients, because different clients do different stuff. So removing those assumptions from the abstractions layers, I think, helped a lot. There's also a third point about simplification, which is also touches upon the server a little, meaning that we have this concept of push and pull consumers in JetStream for a long time. And you can think about it as, of course, they have different use cases, and they were way more different in the past. But when the time was going on, and we're doing other releases with the NAT server, the consumer's capabilities start to overlap, and becoming covering this almost the same use cases. And people are asking more and more. All of us seen it in the chat. So when I should use pull and push, and with every single server release, it was harder to answer in one way. So what we try to achieve in simplification is to lean as much as possible on the pull consumers. So because right now, that's one of the biggest things of the simplification in terms of how users interact, that the pull consumer on the client side always had this fetch method that you can just get set of messages, and often it was blocking until you get all messages, or even if not, you would have to loop it, and it was not as performant in some cases because there was a small break on the networking utilization between one previous fetch finishes and next one is sent. And we realized that with the current capabilities of pull consumers, we are actually able to deliver even better performance than push, or very close in many cases. Depends, of course, use case on use case basis. But with at the same time much better utilization of resources on the client, because the client controls then the flow of messages, meaning that the buffer on the client side can be much smaller, while having the same throughput or very similar throughput. And it's much easier in this way to control the flow of messages, while you still can have this API to get just one message or 10,000 messages, or just this new part of the new API, deliver me messages as like in push consumer, meaning endlessly. And the client will, under the hood, optimize the fetches, meaning it will interleave the fetches, so there is never a pause in delivering them. And that turned out to be pretty well working, and really nice for the. It's especially nice for like IoT or any devices which have very small amount of CPU, network, and memory available, because you can still use this. Those appliances usually have this fetch and iterate over it to just be conservative, especially around memory. And with the new consume, you can just lower how many things can be pending, and have really nice interaction with the NATS client without this compromise of, oh, now the server can flood me with messages until the flow control kicks in. So that was the third point of simplification, adding this new consume method on the pull consumers, which will provide you endless stream or callbacks, however you want to call it, of messages.
Nice. So just to summarize, can we do like a 3-point summary takeaway? If you can remember the points.
It's a quiz for you, David.
Yeah, I failed.
Were you listening?
I was listening, and and now my brain's gone off, and I'm thinking about, that's interesting around the IoT stuff. I'm like, damn it, I've kind of forgot some stuff. So let's, Tomasz, I'm going to put you back on the spot. So big 3 takeaways, starting from the bottom, maybe. Clients now, you can have low resources running them. It sounds like a smoother experience for constrained devices as well. Easier to think about in terms of the approach to streams and consumers. Is that fair?
Less surprises.
Less surprises.
Yeah. And I think going back to the pull consumer too, is that you don't have to like make that choice anymore. You don't have to think about it. So it's gotten to the point that you've optimized this, and you're like, push versus pull shouldn't matter. I think there's still those questions, and the docs still reflect that based on the previous API. But the goal is that shouldn't even be an issue anymore.
So a stupid question then. Can I ask the consumer to go back a number of messages?
If you want to, no, we are discussing it, but usually our answer is, if you want if you consumed, so you can treat consumer as a view or as a pointer into the stream, right? So if this consumer is at, I don't know, message 500, it has its own sequences also, the consumer based of how many times it delivered, etc. So it's always the same or bigger than the stream sequence. And you cannot go back with this specific consumer. But as consumers being pretty lightweight, it's really pretty easy to just remove this consumer, the last sequence you got, when you want to start, and then create a new consumer from the point. So that's how we handle it right now.
Yep. Yeah. So basically just a simple replay strategy then, I guess, up until the sequence that you're looking for.
Yeah.
Yeah. Okay. Interesting stuff. Sounds like a tremendous amount of work has gone on this last few weeks. Or is it months now?
Months.
I'm not sure.
Months.
Yeah. So I think for anybody listening who doesn't know as well, I'm just going to go back to a 210 reference. KubeCon in the Netherlands this year. I think with myself and Tomasz on stage. And what did he turn around and say to me? Can you remember? I think it was...
I was recalling what I said literally yesterday, because I thought about the RC of 2.10, and I was thinking that, we have finally the release candidate for 2.10, and I thought, good that it's before the next KubeCon, because what we said last time, that it's the last 2.9 something release, and it would be...
It was 2.9.17, and you went,
more.
It's going to be the last one. And I kind of looked at you like a scene out of Family Guy. I'm like, really? Doing this?
Famous last words.
Famous last words.
Well,
That was fun point.
Well, we'll have a great, like I said, a great episode on 210. There's been just so much. There's so much to talk about. Not just 210, but the journey over 2.9 leading up, and how much effort and the teams and the people involved to, all the effort with stability, improving things, and crazy testing, distributed systems type testing. Obviously, that is what NATS is, but kind of itself and its own interactions behind the scenes with all the RAF traffic and recovery and all that kind of stuff. There's been a tremendous amount of effort by the team that has gone into that, which has frankly delayed the 2.10 release, because we just keep finding things and keep fixing them, and because we have more and more intense testing compared to like a previous year. So that'll be a fun topic.
And what was interesting also, that while we're fixing it, all of that, what was really good for me, and it was like thinking that it's going into a really good direction, is that every single time we missed something, we tried to add a new tool, a new test, a new overview of the test, to not let it slip again. So it take a lot of, as you said, Byron, it was a really big effort, cross-team effort, that ended up with having us so many more tools available to debug the systems and the servers, and many ways to run the test, chaos test, and a bunch of other stuff. So it was not just fixing the stuff. It was, we missed it, so we need something to not miss it again. Sorry, David.
No, it's all right. No, it's fine. You say kind of way nicer than I was going to say. I was just going to recap the journey from Stan to JetStream, and they are universes apart. I mean, the amount of work that's gone into JetStream. Yes, there's been some kind of teething problems along the way, but the amount of effort going in to kind of get this technology to the right place, to take the kind of power over the top, and I guess the expectations around the NATS core kind of services, and then extend that quality out to JetStream. It's no easy feat.
Mm-hmm. So getting back to, you alluded to it before, getting on to our next topic, which is related in some ways, in terms of at least a lot of the fun client discussions that had gone on around the micro API. So this is another one that's still, to I think a lot of people, nascent. But the people who are like really deep into the NATS, ecosystem, they're like, we really like this. It's a whole new API, new abstraction to work with. It's really pleasant. So can you get into that journey a little bit, and just to sort of cover what the goal was and the path to release it?
Yeah. This is something of our perspective that we sometimes it's hard for us to understand, is that many patterns seem very easy for us to implement as people working daily with NATS, with messaging, and with asynchronous communications. And we're fine with writing those abstractions time and time again. But more often than not, people are really struggling getting into this world from HTTP-based APIs or just into the NATS ecosystem. So this is the origin of many of our APIs. It's for key value, object store, and service API. Those are things that theoretically do not need anything from the server to exist. I mean, theoretically, because key value also pushed a lot of new features into the JetStream, but that was a side effect. Those are abstractions layers that are purely client-sided, which has its own challenges. I will talk in a little later on. But we realized that our perspective, being of course very subjective from the NATS ecosystem, that even for us, it would be useful for those things we do with NATS on daily basis to have a simple way to interact with, to use NATS as a thing that can provide us services, microservices, almost whole microservices approach, you can say, with discoverability, with easily created endpoints, with automatic, reconnects and bunch of other stuff. With very little from our perspective, without any huge efforts on our side, but with really big benefits for our users who don't have to worry about the very details of NATS, how you do things. They can just send a request to some service. That service will give you the response. The service API looks similar to other frameworks that are handling some kind of request. And at the same time, the service provides many things out of the box that is really hard to do without NATS or without this framework, like statistics of the service, like discovering all the service in many different ways, pinging all the services. It's really reaching specific service, getting automatic load balancing, and all of that is built in NATS. But we realized that it's very, you need really good expertise with NATS to understand how to put all those things together. And we were ourselves surprised that if you do put those things together, it really makes a nice comprehensive tool with a set discoverability, with load balancing, with bunch of other features, statistics, etc. And this is one of the examples how the abstraction can provide a lot of value to our users. Because yes, you can do the low-level stuff yourself. It's nothing new on the server. It's purely client-side. But it takes a lot of expertise to do it. You can compare it to interacting with some low-level Linux or APIs, or using some SDK to interact with it via library. You know that it's just some kind of SDK, but it's so much easier and so less error-prone and expressive to do it in a way which is a little opinionated, not very much, but opinionated enough. Then you have to worry about what I want to, about business value. I want to give you give me this request, I want to give you this message, and I don't have to worry about the NATS internals when doing that. Which is very helpful to, again, reduce the cognitive load to our users. And NATS by itself handles a lot with the service API. So did I answer your question?
Yeah, for sure. I guess, and just to, it's always daring to try to describe code on a podcast, but it's one of those things where the first time that I saw the API myself, and I was just like, Oh yeah, and again, like we've all been longtime Nats users, so you forget the beginner mindset sometimes and how approachable something actually can be or should be. And it's like you have this one library, you have this like, at least in the Go case, you have like a struct, you implement a handler that, takes a message in, spits a message out, and you're basically done. And the queue subscriptions behind the scenes, the statistics, the auto discovery, the queue subscription giving you the load balancing in this case, again, using jargon, all of that stuff you just get out of the box, and you're focusing on implementing that one handler. It reminds me very much of like what people, appreciate about like PaaS, where you can focus on that one endpoint, that one function, you can deploy it, and then like magic happens, and then it's simple. So rather than knowing that, yeah, here's all the things that you have to do, and then combine that with, for example, the CLI or any other kind of tooling, you can say like services are up, they're deployed, they self-register, and then you can literally query them, ping them, get stats from them from one unified place, and you didn't have to do anything. It's all baked into that little framework.
And I'm just going to jump right in there. So it's not a static registry either. It's not like something comes up, makes an API call, registers. It's there, it's present, it's always there. And the second it goes offline, then when you do another query to see what's in your it's in your domain, it's not there. It's not. There's nothing having to time out and deregister from a static registry either. So you gain all of these like dynamisms from it, which is really quite nice.
Yeah, it uses the NATS server capabilities again, right? The interest graph of the server that knows who is interested and who is not in what messages. So it's a pretty big deal usually when you have to implement microservices. I mean, there are many challenges when you try to properly do microservices, and it's just NATS solves many of them out of the box, but you need to know NATS to give those capabilities to the users. But yeah, for the scalability, it's really nice that you can just bring something up, bring something down. There's no state whatsoever. No, the abstraction layer we built for the servers API is mostly the contract between the contract what the service instant returns when you ping the specific internal stats info and those endpoints, and very little beyond. So everything else is just using what the power that NATS gives you for that.
And just to clarify as well for anybody listening, there's been 0 changes to the server on this. There's no hidden magic. I mean, I tripped up on this, but there's no JS API shenanigans going on.
No, this is pure core NATS. There's nothing new in the server. It's purely client-side construct. Again, as you said, there's no JetStream involved in it because it's all based on interest graph. And you can say this two things. It's interest graph with subject-based mappings, routing, and the queue groups. Those are the 3 elements that gives you the power of Service API. And what's great, if you don't, many times when I work with some APIs, some technologies, I'm sometimes worried if I can use the higher level abstractions, if it will cut me out of the low level capabilities if I need them. And what's really nice in the Service API that because of it is what it is, just being this thin layer of properly combined pieces, you can really easily interact with it, with services written using Service API outside of the Service API. So it's very easy to mix and match those. So users who want to start easy, but that then want some advanced use cases or something that is not a typical service, they can still they don't have any cost to pay for that if they seem they will need to opt out or do something more, because this is still just NATS, and it's almost like an entry into the NATS ecosystem, because you don't have to understand almost nothing about NATS, to be fair, just very little on the client side. And then when you delve deeper into it, you can seamlessly transition into power user from a simple for the starter of Nuts ecosystem into the power user by slowly getting into the details. So there's no cutting out of capabilities because of using the service API.
Yeah, so it's like kind of minimal work. It's kind of take the library, satisfy the contract, and then stand up some basic Nats infra to get you going.
Yeah, that's lovely. And following on that, not that it was another segue, but it kind of was. This is the client. This is the client journey. So you mentioned, the Microservices API is a nice higher level abstraction. It makes it easier it's purely client side. And so we have getting back to JetStream, we have two other client side constructs as well that have increased in popularity. Again, they're still more or less flying under the radar in some respects, but again, the people who know them, they are taking advantage of them. So you want to get into those, Tomasz?
Yeah, sure. So the first was key value, right? It was actually the first abstraction we built on top of Nuts. And JetStream is, you can say that what I really like about Nuts is that you can say it's building blocks, right? There's core Nuts. Then JetStream is just built on top of core Nuts, is using core Nuts with added persistence and API build. But this is also where the server responsibilities ends, because all the other abstractions, key value, which is again abstraction on top of JetStream, which is on top of core Nuts, is purely client-side construct. And it was the first abstractions that we created and make public. And the first idea was pretty simple. It was, you can actually use stream. You could actually use stream as a key value, because with this subject-based routing, with ability to subscribe to just some parts of the subjects, it was pretty easy to imagine that key value would be possible. And maybe not super performant, maybe not fighting the strongest key value stores out there, but yeah, it should be doable. And that actually pushed server a lot, because we realized, I think that max message per subject stream configuration option was created purely because it was needed for key value, because this is again nice things about the abstractions layers, that they use Nuts internals with as little custom opinionated code as possible. So when in key value you can have a history of 10 messages, it's actually just a stream configuration saying max messages per subject, and this option onto the stream was added because we needed for key value. Well, but what's interesting, we now realized, our friend Jean-Noel realized that, thanks to that, you can have infinite duplication of messages if you set it to 1. And a bunch of new use cases popped up because of the things. So yeah, key value is an abstraction on top of JetStream. Nuts server does not have to know that a given stream is a key value store, but we did improve the Nuts server features and performance optimizations. We did a lot of them to make key value better. So it was almost like a benefit for both, for the server and for the streams. The streams benefited from the key value, adding some new features and finding some new weak spots that we could fix. And I remember joining the company and talking on the KubeCon again 2 years ago. It was in Valencia, and I said it was 2.8 release, and I remember saying it's recorded that the key value is just it was simple to do, quite simple on the client side, and we thought it would be great if users could have a key value available at their fingertips, especially if you use leaf nodes and big topologies, when you might be in factory floor where you want to have as little infrastructure and tools installed as possible. So if you get key value for free when you use JetStream and NATS, it's a great benefit for those. But we don't try to be super performant or super fast. So it's just as for simple use cases. And well, it didn't age well. This is what I said, is just for simple use cases, because it's almost a year and a half later, there's this key value being able to be used as a Kubernetes persistence layer instead of etcd, and people creating bigger and bigger stores, which are actually way beyond what we said as simple use case with huge amount of keys and values. So a simple abstraction that outperformed itself in its adoption. So that was that. But it's also we realize it's very challenging to deliver it cross clients, to put some stone from my garden of challenges we had with those abstractions layers, because we realize that usually when we write the clients, if we write the tests, if the server responds to our requests with, okay, yeah, you're fine, you're done. It means we are okay, more or less. It's simplification, but still. But when we work on abstraction layers, like key value objects or service API, server does not know that you're using some abstraction layer. So you have to make sure that each client is actually, that you worked with key value for a year in Rust, now you're picking Go, and suddenly the bucket does not work with the other language. And server will not help you here, because it's just an abstraction layer, some opinions on top of some use case on the JetStream. And this is, I didn't want to do it, but this is a kind of segue to object store and its current state, because we thought its APIs as it is, it's fine for the first iteration at least, but we didn't feel confident about its compatibility across all the languages that support it. So we put a lot of effort before saying anything about it's not being any experimental anymore, that we need to be sure that when you use it on Go, and then you start adding in Rust and in JavaScript and in .NET or Java, that each of the bucket will work when you put it here, get it there, update it here, etc. And for that, we created the it's a small thing, but a tool that tests and asserts the results across all the languages. So that was what was stopping us from removing the experimental flags, because you want to make sure on object store that everything is working with each other. Because imagine that it did not, and we found some bugs, and then somebody used it in production, and it's a really hard to deal breaking change, because if you change something, you need to migrate the opinions from the old bucket to the new one. So that's one of the challenges that we faced with working with those abstractions layers. And it's the same for service API, for key value, and for the object store, that we need those tests, and you are writing them for each of the abstractions layers. So I will go back to key value in a second. Though I think we said so much on the key value subject elsewhere that I'm not sure we need to dwell with it very deeply.
Yeah, one just to put a double point on what you said there about these are client-side abstractions, so that the contract is so important. And for those who don't know, even if you're a NATS user, you might not be aware, the team does a really diligent job of maintaining these architecture decision record documents that actually go into the design, go into sort of the semantics, go into this data contract. And there's a lot of activity that goes on in those to have a centralized document that's agreed upon, that then is used effectively as a spec for the client devs to work and implement. So that could be some candy for some people. They might say, "Oh, I want to get into the weeds, into the brains behind all of these sort of details." And there's a whole public repository under the NATS.io organization that you can get into to kind of check out some of those artifacts.
Yeah, and while we touch this, it also touches the tool I mentioned, and we discussed it. For the testing the compatibility of the clients. We realized we have this ADR repository of design decisions and discussions, but we realized that no matter how hard you try to define the spec, it takes a lot of time to thoroughly go through it for every single engineer and maintainer and implement it in exactly the same way. So one of our current ideas is to use this testing tool to do something like test-driven spec. So when we write a new feature into the ADR, we also write a test for it. It's in progress. It's not yet fully done. And then the maintainers, and does not touch only Synadia employees. It touches every single client maintainer from open source community too. We want people to spend less time trying to be sure that what they understand is what we meant when writing those ADRs, because that takes a lot of time. You spend like 3 times more time writing more tests, but it's still all with the assumptions you make around the implementation. So we are not done yet with this. We didn't make it as a part of the process yet, but we really love to. Is that the users can, when we add new abstractions layers, because they take some time because of all this possibility of having miscompatibilities and basically not working with each other. So to cut the time we need to deliver a new feature and to make it easier to the maintainers of open source libraries, that they can just read the doc as a design doc and then just make sure that the tests on the cross compatibility tool is green. It means, yeah, they understood it correctly, or we were expressed it correctly. And we hope that it will really help not only ourselves internally at Synadia, but also all the open source contributors, which I think are great value. We see more and more. This is a whole new podcast we could have about the engagement that is really growing on, especially on some repositories and some even open source whole clients. And we really should try to make as easy as possible for the folks to contribute and understand what needs to be done. Yeah, sorry, it was a digression from digression.
No, that was perfect. That was great context. You have any thoughts, David, on all of this?
Not really. I first of all, since the KVs came out, I've been a massive user of it. I think between core, pub sub, request reply, KVs are literally the next thing that I've started leaning into really heavily. It's powerful, especially when you include the watcher functions or the callbacks. Anything changes, you can respond to those things. So that whole polyglot approach then only becomes more important. If I'm writing code in JavaScript, dare I say JavaScript, bit of Python, primarily Go, at least I can be assured and have confidence that what I do across those languages is all going to give me the same user experience. All this is, the work involved is really, really important. But the thing I know very little about, and I'm probably going to hear from you in a moment, Tomasz, and you're going to say, it's just KB but bigger, is around the object store.
So how does that work?
Yeah, hit us up. Spill the beans.
It's not exactly key value, just bigger. To be fair, just one more thing before I get into the object store details is what you said, how you use it. And it's something that we find incredible is that we provide some small abstraction layer or bigger, and we just think maybe somebody will use it. And then we hear about how people use it and about the use cases we didn't even think about. And it's really incredible how the community and users drive the things we're trying to make and contribute ourselves, because the use cases many times just blows our minds with ideas people have, and we then embrace them and try to improve the APIs for those use cases.
I've got a suggestion for you, by the way. One of the things I've ran into, which is, it's not a problem, it's just a bit of a niggle. Transactional updates across keys would be ace. and then a watcher that's triggered once when more than two keys have been updated. Just saying, we could put on the list. Bit of nepotism doesn't really go far away.
Just add transactions, multi-key.
It's fine. It's easy, right?
It's fine.
Yeah.
Manual talents.
Obviously, we have discussions about those things, though this is usually bigger topic than we ourselves can embrace. But yeah, that's something that is being discussed, but it's a wide change across so many levels of the whole NATS ecosystem, especially server. So definitely just don't get your hopes low. This also don't expect it to be very soon, but that's something you would love to have, but it has to be done right? It cannot be any kind of workaround on the server side. It has to be really strong effort to get this. Going to the object store question, I think it's how we can describe it. One of the reasons why we needed it is NATS is not very, but it's constrained on the size of the payload of messages. Yeah, you can increase it, but it will impact the performance and responsiveness, you can say, of the server, and it's not advised to go beyond some few megabytes of the max payload size of each message. And it sounded like a low-hanging fruit, to be fair for us, that but you can chunk the messages. But it sounds simple, but anybody who dealt with chunking of some bytes know how easy it is to mess this up and have a bunch of errors. And this is but this is quite tedious work. You know what you have to do, you know how. But we imagine, and we were asked a lot about bigger payload size. And every single user have to do this chunking, checksumming, thinking how structure the NAT subjects, how the stream config looks like. So we thought, we can with our expertise, we can just deliver. You don't have to think about it. You can just use it. And we don't try for the object stories. We'll see what it will say in a year and a half, because I just said that key value, I said it just for simple use cases, and hear me not learning my lessons again.
So what I just said before then is it's like key value, just a bit more. You just kind of described that. You've took the experience of the key value, you take the same approach, and you put some opinions into some helpers around object store.
Yeah. We try to be in the clients not very opinionated, because more opinionated you are, more like a framework you start to look, and the opinions are not always, but maybe not limiting use cases, but putting people in box of how you think about what you can do with this API. And with this API, yes, we want to remove the burden of with understanding how you should approach NATS to do specific thing, because NATS being so powerful it's so powerful on 3 levels: scalability, then on topologies, which is a huge subject on its own, and on persistence layer. And it's really, there are so many ways you could do it, and that's what we try to do is to remove the need to think about it every single time for every single user how to do it. It is kind of an opinion, but it's an opinion how to create a bigger message, a bigger blob, however you want to call it, file in NATS, how to store it, rather than a full-blown storage framework, however you want to call it. So it is simplistic in its API nature, but it also enables more use cases, I think. And it's also always a challenge when we discuss those. So should we put this option in, or it's too much of an opinion, or you just need it because everybody wants it? It is the same approach as with key value, meaning we just put some specific configuration of the stream and of consumers on top of JetStream. for object stores, we didn't, I think, change a single thing for that server. Maybe some optimizations, but not new single API calls. I don't think so, at least. Nothing significant for sure. So it's just an opinion, and we again didn't realize that the chunking part was an easy part, but what would made it really different for our users, who even didn't need IoT implementation for object store for easier storing of messages because they use NAT. So let's give them also object store, but the watcher feature, which is a internal part of any JetStream messages, let's call it this way, because consumer is just can be treated as a watcher with different configurations, what you watch, how you watch. It actually does make a difference for many users because it's not that simple to do with other stores. So this is what kind of surprised, not very surprised us, but surprised us how big difference it can make for some of our users. But that's just putting an opinion on top of JetStream, or rather maybe not opinion, maybe some, not a framework, but some frames in which you operate with JetStream that gives you this specific use case, right? So JetStream is a big thing of possibilities, and this is giving you this specific use case in pretty unopinionated way, but with use case in mind. So
yeah, and I think that's a good framing, because I think it's one of those things. It's like you get questions in, from the community, or you think about the problem of like, all right, we know, the max payload, the max size of a message can be X. If we up the limit, which is a server side configuration, then, memory buffers and all this kind of stuff are potentially affected by that. And so the general question of how do I shove a giant object into NAT or pass it through NATs or make it available in NATs? And it's like, right, chunking. Okay, that makes sense. And then I think that pragmatic approach of being conservative with the API in particular, just like with KV, it's much easier to become liberal over time and expand it. But if you just say, we're going to be, S3 compatible out of the gate before we've even proven out, whether this is going to be of use to people, I think was the right decision. It's to keep it real tiny, keep it small, and also expose through the API the things that we can leverage, like the watcher. So for people who don't know, you put an object in, you delete an object, you update an object, and you get events through the watch API when those things happen. And then you can choose to, react to those events and do something if you need to do whatever. And for free, and this is not to get into technical weeds, but again, it's this layering approach of saying, because it's based on the stream, both KV and object store, for free, you basically get mirroring, right? You have all that same sort of distribution model that you get with streams and replication and all this kind of stuff out of the box. And so you have distributed KV, distributed object store. You can create mirrors, read-only mirrors in, push it down to edge locations. And so objects will just flow, KVs will just flow where they need to go based on those mirror definitions. And you can still keep, a small API there, but you get all of those other benefits without any more dependencies. And that's the power and the beauty of this, going even back to the services API too. It's like load balancers and service discovery and all these things, no extra dependencies. It all just is part of NATs and these client abstractions, and it's a beautiful thing.
I think it's so when you ask about, tell me about object store, even if you in NATS ecosystem, even if you narrow the question to specific element of it, as you said, it's sometimes we ourselves do not realize, or we forget, like, this is just chunked messages. But you can actually mirror it to the whole globe, because for us it's like natural. And you can source it, you can mirror it, and actually it's just a normal stream underneath. So again, you can do things with it. We are not restricting it in any special way. So you can interact with the stream in normal fashion. So again, if the object store API is not enough for you for some reason, you are quite often not blocked because you can have some workarounds. And if this workarounds looks like a pattern in the whole community, then it will be considered as part of the API. But what's interesting is that what you said is like, I forgot about the mirrors and stuff because there are so many of those aspects. And I think that's the most beautiful things about all those abstractions layer we built on top of Nuts is that they don't have to be very smart or do very much, because all they have to do is to make sure that they use idioms of Nuts itself, and then you can leverage the full power of Nuts distributed topologies, leaf nodes, superclusters, replication, and we can go on.
Yeah, some seriously powerful features and capabilities, and I think certainly for me, Nuts has been absolutely game-changing. I mean, it was already great, but then you take the KV, you take the object store, and all of a sudden, I'm finding it so much easier to build things. Like logic for checking for changes, I don't have to worry about it anymore. If I want synchronization across, I don't know, multiple browsers for an application, I can just put a load of watches on a key value, and I don't have to worry about all that stuff. It's absolutely fantastic. Some of the work that's been going on, incredible. So, I mean, we could probably summarize some of this stuff. So can we take, I'm going to do like a pop quiz. You ready for this? And you can't ask me, right? Because I've been daydreaming for most of this and I've been fascinated listening. But anyway, so let's take 3 things for JS modernization, 3 things for KB, 3 things for micro, and 3 things for object store. So 3 things to take away for JS modernization. What are your top 3 big ones?
I think that the most important part is reducing the cognitive load. This is the biggest one. It kind of forces people into learning just the basics of JetStream, but also splits this many things happening in one method into 3, usually 2 free methods calls. And this is the most important part of the simplification. And the second one is making it idiomatic more idiomatic per language. And this is benefit for all our APIs, future ones. So we have some standards across all the libraries in different languages that we follow and we know what to do. And the third one is to lean on the pool consumers to also, again, simplify and have less decisions to be made by the users, and to provide some new patterns for the pool consumers. So we use only one type of a consumer most of the time, but our users don't lose any patterns or features because of it. Yeah,
so lovely.
No, I like
those.
Byron, anything to add? The 4th one?
No, that was great. That was great.
4th, you're going to break the rule of 3 here, even though we've got 4 topics. So I guess we could go with the 4th. Next one then, KB. 3 solid points for KB.
It's a good one because, again, we just take things for granted at this point, but it's like, it's not a new dependency. You can still have the KV API and the appropriate abstraction, I think, is the thing. It's like, naturally, you have services, you have messaging going on. You're like, I need to store a little bit of state. I don't need a stream maybe, but I would love to just use a little KV bucket. It's like, it's more approachable in my opinion. So it's something that you can just, grab and just use out of the box. Even if you're not doing, stream processing or whatever, there's a KV bucket and you just use it. And that's really nice.
So easy to use. Okay.
Second one is, I think, that all the topologies, that you can get all the mirroring and stuff almost out of the box. And it translates to basically having key value available mirrored across the whole globe, across all your IoT and stuff like this. And the third one, probably the watchers, but it is a cheat because we'll use the same for object store. But that's fine.
I've got a 4th actually. I'm going to break my own rule here. The thing with JetStream and the KV is, even if the data is located in one cluster in one region, you can still access it, even if the data is not local present. It's not in your local area, and that's something a lot of people don't seem to think about. I think if the whole NAT system or parts of it are JS enabled, you can still access the key value store from a different location where the data isn't. So you've got accessibility. Anyway.
Yeah.
It's a tiny little point, but something that surprises people.
The data locality option that you can make it available. So I guess object store, like you said, Tomasz, is pretty much the same in takeaways, right?
Chunking, easier, mirrors.
Yep. So what about the Services API? Let's go through 3 points for that.
Yeah, I think that for the most part, this is just what NATS gives you, which is the most important part. The first one, I would say that when you create microservices, infrastructure, architecture, however you want to call it, the challenges of scaling instances and discovering them is one of the really big ones, especially when you scale them. So I would say that the easy scalability, which you can say it's out of the box scalability, because you get more instances by just running more instances of the service. You don't need anything to manage it for you. There is no state. It's just smart interest graphs of the NAT server that does all the work. I think that's one of the really big important parts of the service. The second one, I would say, is the ability to have these different ways to interact with the services, meaning that you can get very easily statistics, get pings, so all alive instances. And it's, again, this is part of just NATS features, capabilities. So you can say that the clients, we did very little work. We're just saying, yeah, we delivered this new thing, but actually we just wrapped the whole power is in the server side and the NAT side of the things. And the third thing is, I think that the entry, how easy it is to as an entry thing into the beginners of the NATS ecosystem, because most of us wrote some kind of services, if not microservices, and you have some ideas how microservices should be and how they should work. And if you try to use the Service API, you don't need this knowledge about NATS. You can just play with it almost instantly, and you can learn NATS through it, which I think it can be really beneficial for some that you don't have to, using Service API, you don't have to grasp the whole asynchronous messaging stuff. It allows you to slowly get into it.
That was a wonderful final point of saying these abstractions allow you to learn NATS, from front to back more so, or top down rather than bottom up in a way. So you can understand most people have written an HTTP handler, a request reply. This basically provides that abstraction in a simple way. And then you can, learn more of the details when you need to do more interesting things. But that's a really good entry point for people to learn for sure. And then similar to KV, everyone knows what a hash map is, a KV, right? You just pick it up, you need to store some state and you grab it, and that's it. And then object store is object store. So that's great. Any final thoughts, David?
All I'm kind of I just want to put myself in a corner now with some IoT kits and PLCs and play around more with some of these ideas. To be honest, I'm going to work with this tech every day, but every day there's more ideas. So I'm just, as always, blown away. Happy to be a passenger on this one, really, and just listen in. It's been an educational one. So I guess that brings us though to the very end. So Tomasz, thank you very much for joining us. This has been, certainly on my part, a really interesting ramble through some really quite, I think, heavily invested in features, some real solid engineering. I think Synadia and the NATS community's learned a hell of a lot about the kind of things we're doing with JetStream, and it's been a pleasure to have you on this as we go through. And then I guess we'll probably have you again for 210. So there we go. How about you, Byron? Any takeaways?
I think we went through our bullets, but yeah, I really appreciate you coming on, Tomasz, and it's there's just a lot of wisdom, experience, and it's fun to kind of go under the covers and try to understand, design decisions. And I know as a prior to really working with the Nats team, you can take things for granted, and you're like, oh, I want this feature, I want this, but it's like there's a lot of discipline and a lot of thought that goes into the clients, the servers, the abstractions, all of these things that are from a person who, as a user, they're simple to use, and simple is hard. Fundamentally, it's really hard to get right, because you have to push things aside and say, we're only going to focus on this one little bit. You want to have a certain developer experience. And so my takeaway is that I think you did a great job articulating some of those aspects and reasons why, and the sort of stuff that goes into all of these decisions, at least on the client side and elsewhere. So thank you for that.
Tomasz, anything you want to leave the listeners with?
Yeah, thank you for having me here. That's for the first thing. Yeah, we're just using the power of nuts, but that's the whole, or all the kudos should go. It really enables. It's mind blowing how many use cases it can enable with just some small abstractions layers. Where the hardest challenge is how to make these APIs well balanced. Yeah, and one more thing is that as you hear, we are surprised by many of our use cases. We see by our users how they use our APIs, our abstractions layers. So we are very always eager to hear about those use cases and about ideas. Just don't shy, just throw them at us. We will see how they fit to different places, because nuts can be used in so different ways that probably the users are the ones who can tell us in how many ways it can be used.
And that's another beautiful segue. And on that note, I think always where humans meet technology, there is a horrendous barrier. We've done an enormous amount of work to try and narrow that gap. Thanks everybody for listening to this. If you're watching on YouTube, hit subscribe. If you're listening on your favorite podcatcher, please just subscribe. Give us some messages. Join the Slack Nats community groups. Come and say hello. If there's anything that you want to hear about, come and tell us. And thanks again. We'll catch you next time.
Nats is brought to you by, why can I never say that?
So
Nats FM is brought to you by, see, we've done this 4 times and I still can't even get it right.
I missed off Sinead the other day.
Yeah.
God damn it.
It was like Nats FM is brought to you by the stewards of the Nats project.
Of some project.
It's like, it sounds ridiculous.
There's that company that nobody knows that's behind it, and we forget the name.
Sounds redundant, yeah.
Every episode is different. It's great.